Good morning students, welcome back to the chemistry classes, and from today onwards we are going to start our third semester, and in today's class we are going to start our very first chapter of the third semester. So before that I would like to tell you that what are the chapters which are included in our third semester. So we are going to study about the hydrogen, water and carbon. So these are the three chapters which are included in your third semester. Okay students, and I hope that all of you have done your second semester exams well. Okay, so in today's class we will study about the hydrogen. Okay, so let's start with the lecture. Okay students, so let's start our third semester with our very first chapter, that is hydrogen. Okay, so this is chapter 7 in your book. Okay, so from the 6th standard you people are hearing about this term hydrogen. Okay, so in this chapter we are going to study about this element hydrogen in detail. Okay, we will see how the name hydrogen came into existence, then in what are the states it exists, then we will see its preparation. Okay, so and then we will see some of its properties also. So let's start. So first of all, let us see this, that hydrogen is the lightest element on the earth. Okay, so hydrogen is what? It is the lightest element on the earth, and it was first prepared by an Irish scientist. Okay, so who prepared it? Irish scientist, which is what? Robert Boyle. So he was an Irish scientist who first prepared hydrogen by the action of dilute sulfuric acid on iron nails, as you can see in the figure. Okay, so this is how Robert Boyle prepared hydrogen. Okay, this is how the very first experiment was done for preparation of hydrogen. Okay, then Cavendish studied the gas and called it inflammable air. Okay, so it was called what? It was called an inflammable air. Why? As the gas burns when kindled. Okay, so that is why hydrogen is what? An inflammable air, because it burns when kindled. In the presence of oxygen, it burns. Okay, so here this is the reaction which will take place. Okay, I have told you Robert Boyle first prepared the hydrogen by the action of dilute sulfuric acid on the iron nail. So this is the reaction. When iron reacts with the dilute sulfuric acid, ferrous sulfate and hydrogen gas evolves. Okay, so this is how the hydrogen gas was prepared. And in this figure, as you can see here, it is shown that hydrogen is an inflammable air because it burns in the presence of oxygen when it is kindled. Next, now let us see the occurrence of hydrogen. Okay, so hydrogen is the most abundant element in the universe. This you should remember. Hydrogen is the most abundant element in the universe. Stars are mainly composed of hydrogen. Now stars, including our sun, is mainly composed of what element? Hydrogen. Okay, now in the universe it is in the abundant state. Okay, it is in abundance. On earth, hydrogen occur in very small amount in the free state. This is to be noticed over here. Hydrogen in universe exists in free state in abundance, but on earth hydrogen occur in very small amount in the free state, which are what? In air, in volcanic gases and in the earth's crust. So these are the various places where you will find hydrogen in the free state. Okay, and that is very small in amount. Okay, but there is plenty of hydrogen on earth in the combination with other elements. Okay, it is found in combined state in plenty as the part of various compounds. So there are various type of compounds which have hydrogen. So we can find hydrogen in combined state in plenty amount. Okay, this is to be remembered. On earth, hydrogen is in very small amount in the free state, and in the combined state it is found in plenty. Now let us see some of the examples of the compounds in which we will find hydrogen in the combined state. Let's see. For example, water is an important source of hydrogen, which you already know. In combination with carbon, hydrogen is present in various hydrocarbons such as natural gas, diesel, petrol, LPG, which is known as what? Liquefied petroleum gas, CNG. What is the full form of CNG? Compressed natural gas, etc. So these are some of the hydrocarbons. So about hydrocarbons you have already studied in the second chapter. Okay. So what are hydrocarbons? Hydrocarbons are those compounds which are made up of hydrogen and carbon. So these are some of the examples in which the hydrogen is found in the combination with carbon. Now, acids and alkalis also contain hydrogen. This also you know. What are some of the acid? Sulfuric acid is what? H2SO4. So here also we find what? H. Then HNO3. It is also having what? Hydrogen. Okay. Then what about some of the bases? NaOH. Okay. Aluminium hydroxide is also having hydrogen. Okay. So various bases are there and various acids are there which are having what? Hydrogen. Okay. Let's see next. Now, let's see about the preparation of hydrogen. So in this we are going to discuss about various methods by which we can prepare hydrogen. Okay. So there are various types of method by which we can prepare hydrogen. The very first method is by displacement reaction. So about displacement reaction you have already studied in the 6th chapter. We have studied it under the category of various type of chemical reactions. Okay. So let's see it. As we know, hydrogen is available in the combined state. Just now we have seen that hydrogen is found in the combined state in plenty. Okay. And it can be obtained by displacement reaction. Because it is found in the combined state, it can be obtained by what type of reaction? Displacement reaction. Now, in the displacement reaction, we have seen about the activity series. So this is the activity series about which you have already studied in the previous chapter. Okay, and have told you to learn about this series. Okay, I have told you to learn the metals. Okay, these metals are arranged in the order of their activity over here. Okay, so what we have seen, the metals which are above the hydrogen are more active than the metals which are below the hydrogen. Okay, similarly, as we will go from bottom to top, reactivity will increase, and as we will come from top to bottom, reactivity will decrease. So this is how the metals are being arranged in the activity series. Okay, so here also what is written? We have already learned that in the activity series, metals along with hydrogen are arranged in the order of their activity, and a more active metal displaces a less active one from its compound. So this already we have seen in the previous chapter, that more active metal displaces a less active one from its compound. Hence, metals above hydrogen in the activity series can displace hydrogen from water and acids. Okay. How we came to know? Because the metals above the hydrogen are more active, and that is why they can displace hydrogen from the water as well as acids. But below the hydrogen, whatever metals are there, they will not displace hydrogen from water and acids. Okay, students, remember this also, that this silver, gold and platinum are noble metals. Okay. One thing you should keep in your mind, that silver, gold and platinum are what? Noble metals. They do not show any kind of reactivity, okay? They are noble in nature, they are neutral in nature. This is to be kept in mind, okay? But it should be kept in mind that lead and tin do not undergo this reaction with water at normal conditions. Okay, so these are some of the exceptions which you have to keep in your mind, that lead and tin, these two metals do not undergo this reaction of displacement with water at normal condition. Okay, at high temperature they can undergo such reaction, but at normal condition they do not undergo such type of reaction. Now why it happens so? Due to the protective layer on their surface. So there is some protective layer on the surface of tin and lead metal which prevent them to react. Okay, so this layer prevent their reactivity. That is why they do not undergo such type of reaction. Okay, and one thing more, and also lead do not react with acid. Okay, this is to be kept in mind. Lead and tin do not react with water at normal condition, and lead do not react with acids. Okay, so these are some of the exceptions which you have to keep in mind. Now here we are going to see that how some of the metals which are highly active, okay, so we have already seen that metals which are above the hydrogen are active and they can displace hydrogen from the water. So let's see how it happens. Highly active metals like sodium and calcium vigorously reacts with water, displacing hydrogen from it even in cold condition. So these metals such as sodium and calcium show displacement reaction even at normal temperature, that is in cold condition. We need not to provide any external energy from outside for this type of reaction to happen. Okay, so as you can see here in these reactions how sodium is displacing hydrogen from the water and how calcium is displacing hydrogen from the water. So when sodium reacts with the water, what is formed? NaOH, sodium hydroxide, and hydrogen gas is being released. Similarly, when calcium reacts with the water, what is formed? Calcium hydroxide and hydrogen gas is being released. So you can see over here what is being displaced. Here the hydrogen is being displaced by sodium, and similarly here hydrogen is being displaced by calcium. Okay, now let's see a less active metal like magnesium. So as you will go down, what I have told you, reactivity will decrease. So here potassium, sodium and calcium are active metals, but magnesium is what? Less active. So a less active metal like magnesium displaces hydrogen when steam is passed over it. So this is the condition required by the magnesium to show displacement reaction in the water. So what is to be passed? Steam. Okay, steam is to be passed over it. Okay, so here you can see water is there in the steam form. Okay, and magnesium reacts with the steam, and then magnesium oxide is formed and hydrogen gas is being released. Okay, similarly a still less active metal like iron displaces hydrogen when steam is passed over the red hot metal. Now this is the condition. Before we have seen what? Magnesium displaces hydrogen when steam is passed over it. But here for the iron to show displacement reaction, what condition is required? Steam is to be there and the metal should be in what condition? In the red hot condition. Then only the displacement reaction will occur. So when iron in the red hot condition reacts with the steam, what is formed? Ferrosulfuric oxide and hydrogen gas is being released. So this is how the displacement reaction happens, okay, with metals. So here what we have seen, how hydrogen is being displaced from water by certain metals. Some metals react vigorously, some metals require some of the conditions for them to displace hydrogen from water. So these things is to be kept in mind. Now let us see how metals displace hydrogen from the acids. All metals above hydrogen except lead. So this we have seen just now. Except lead, all metals above hydrogen, okay, all metals above hydrogen in the activity series displaces hydrogen from an acids like dilute hydrochloric or sulfuric acid. Okay, this is to be kept in mind. All metals except what metal? Lead. Okay, so this can be asked in the question, which metal do not displace hydrogen from acid. Okay, so what metal we will say? Lead. So lead is that metal which do not displace hydrogen from the acid. Okay, now one more exception is there. Nitric acid, HNO3, is not considered for this reaction. Okay, so this question can also be asked, that which acid is not considered for such type of reaction. We do not consider nitric acid for this reaction as it gives the oxide of nitrogen. So this is why, that is why we do not use nitric acid in such type of displacement reaction. So let's see how sodium displaces hydrogen from hydrochloric acid. So what is formed? Sodium chloride and hydrogen gas is being released. So this is vigorous. This is vigorous reaction. Why this is vigorous reaction? Because it happens with what metal? Sodium metal, which is highly active metal. So sodium, potassium and calcium are certain such metals which are very active. That is why they show vigorous reaction. Okay, and let's see how zinc displaces hydrogen from sulfuric acid. Okay, zinc sulfate is formed and hydrogen gas is being released. So this is moderate reaction. Okay, because zinc is not very much active as compared to sodium, calcium and potassium. So these things you have to keep in mind while you study about the metals. Okay, next. So the next method by which we can prepare hydrogen is by electrolysis of water. Now this method you have already studied. Okay, we have already studied how the hydrogen and oxygen gas is being obtained. But our motive here is to obtain what gas? Hydrogen gas. So let's see the decomposition of substance in the molten state or in the solution when electric current is passed through it is called what? Electrolysis. So this is what? Decomposition of substance. In the molten state is what? In the liquid state or in the solution. When you will dissolve anything in a solute, that is what? Solution. Okay. So in such type of substance, when decomposition occur through the what? Through electric current. So it is what? Known as what? Electrolysis. We know that acid-related water decomposes into hydrogen and oxygen when an electric current is passed through it. So this we have already seen that only acid-related water undergo decomposition. Okay, the substance taken in the molten state or in the solution is called what? Electrolyte. So this is to keep in mind. Okay, the terminals made of metals or graphite through which the current enters or leaves the electrolyte are known as what? Electrodes. So these are what? Electrodes. Okay, so what are electrodes? The terminal made of metal or graphite through which current enters or leaves the electrolyte. So these are what? Electrodes. Okay. The electrodes connected to the negative pole of the battery is called what? Cathode. So this is the terminal which is connected to what? To the negative pole of the battery. So that is known as what? Cathode. And the one connected to the positive pole of the battery is known as what? Anode. Okay. So these things you have to keep in mind. So the pole which is connected to the negative pole of the battery is known as what? Cathode. And the electrode which is connected to the positive pole of the battery is known as what? Anode. So these things you have to keep in mind. Okay. Now the vessel in which electrolysis is carried out is called an electrolytic cell. So this is what electrolytic cell in which electrolysis is being carried out. So this was all about the structure, okay, the setup, or you can say the setup which is required for the electrolysis to carried out. Next, remember, electric current passes through a compound in the molten state or in solution only when the liquid contains ions. So this is very important to remember, that in the presence of ions only electric current can pass. So it is very important for the compound in the molten state or in the solution to contains what? Ions. So that means what? That substance or that compound should be ionic. Okay, that should be ionic. Hence, only those substances will act as electrolytes which are made up of ions or form ions in the solution. Okay, only such type of substance we can use for the electrolysis, which are made up of ions or forms ions in the solution. So very good example is what? Sodium chloride, which is made up of ions, sodium ion and chloride ion, and it also forms ions when it is dissolved in the water. So these things are very important and should be kept in mind, that we can use only those substances for the electrolysis, or we can use them as electrolyte which are made up of ions or form ions in the solution. Pure water do not allow an electric current to pass through it. Okay, pure water do not allow. But water is related with small amount of dilute hydrochloric or sulfuric acid does, because it dissociates into ions. As you can see here, this is acid-related water which dissociates into its ions, hydrogen ion and hydroxide ion. Okay. So it is very important for that particular electrolyte to dissociate. That is why we do not take pure water, because it do not dissociate. But acid-related water dissociate. That is why we take it as electrolyte. During electrolysis, the H plus ion move towards the negative electrode. Why? Because it is positively charged. That is why it moves toward what electrode? Negative electrode, which is known as cathode, and get discharged to give hydrogen, which we have seen already. Next, and the hydroxide ion move to the positive electrode. Why? Because it is negatively charged, and hence it will move towards what electrode? Positive electrode, which is known as anode, and get discharged to give oxygen. Okay. Now here you can see the reaction. Water is dissociating into hydrogen ion and hydroxide ion, and at cathode what is happening? At the cathode we are getting what? Hydrogen gas, and at the anode we are getting oxygen gas. So this is how the reaction takes place. In actual, instead of hydrogen ion, it is hydronium ion, H3O plus ion, which is made up of hydrogen ion and water, called the hydronium ion, which I have just now I have told you, that exists in an aqueous solution. Okay, generally we say what? Hydrogen ion is there, but in actual what ion is present? Hydronium ion. So, okay, about this you will be learning in the higher class. So in today's class we have seen two methods by which we can prepare hydrogen. So very first method was by displacement reaction, okay, which happens with the help of activity series. Okay, then we have seen about the electrolysis of water. So these are some of the ways by which we can prepare hydrogen. So there are some other methods also, okay, about which we will be studying in the next class. Till then, whatever we have studied today, study it and underline the important points. Okay, start underlining the important points. So while I am giving this presentation, I highlight some of the terms, okay, for you to learn those terms, okay. So learn all those terms, okay. That's all for today's class. Thank you.